All right, hello everyone. Today what we're going to be looking at is our next step on really trying to master how and why materials are interacting in the certain ratios that we're seeing in our chemical reactions. So we're going to be focusing on this thing today, which is called stoichiometry. So stoichiometry has like this really lofty name, but really if we want to go through and define what stoichiometry is just the process of balancing a reaction to help define the ratio of materials to then connect and track the amount of matter being used. Okay. So with stoichiometry, we're taking all of the skills that we've been practicing up through now. So finding molecular mass, plus us being able to find molar mass, plus balancing and dimensional analysis. All of those different skills are going to come together in this culminating thing where we're going to be balancing chemical reactions to help us find and figure out how much mass we might need or predict how much product we might get in a particular chemical reaction. Okay, so I think the best way to do stoichiometry is to go about an example, right? And then looking at that example to see the steps that we took in order to solve the problem, okay? So when setting up these kinds of questions, I might ask you, or might say that given a chemical reaction, how much of something is needed to react to some given reactant? Okay, so you might get a question that looks like that. Okay, so something like where I give you some kind of mass or some kind of number of molecules, and you've got to tell me exactly how much I would need in order to get, say, a completely efficient reaction, right, where everything is utilized. Okay, so let's do an example where I'm giving you this chemical reaction. So the first thing that I need to do whenever I'm doing any kind of stoichiometry is I need to balance my reaction to make sure that what I'm looking at is what's truly happening in a reaction, so that I have the same amount of matter before in my reactants as I do in my products. Okay, so looking at this chemical reaction, I can already tell that it's not balanced. I have an indiscriminate or unequal number of hydrogens and an unequal number of oxygens on both sides of my reaction. Okay, so just going through my steps of balancing a chemical reaction, I've got carbon, hydrogen, and oxygen on both of the sides because this is a combustion reaction. So those are going to be my elements. So let's start with carbon. With carbon, I've got one here. I've got 4 hydrogens and 2 oxygens. On this side, I've got 1 carbon, 2 hydrogens, and 3 oxygens. Okay, so let's balance my hydrogens. So that's going to require me to put a 2 here, which would give me 4 hydrogens. That changes my number of oxygens to 4. So to balance this side, I need to put a 2 in front of my O2 to keep it balanced. Okay, so when you're looking at these balanced reactions, you are looking at the ratio of moles needed to have a reaction. So essentially what this is telling me is that for every 1 mole of CH4 methane gas, I need 2 moles of oxygen gas to give me my product of 1 mole of carbon dioxide gas plus 2 moles of water. Okay, so again, a molar mass or a molar ratio, right, is just that you have that many of something. Again, remember 1 mole means that we're going to have 6.022 times 10 to the 23rd of that substance, right? So either atoms, molecules, ions, whatever thing we're trying to measure. Again, this is just a number. Okay, so that's how many that we're going to have. Okay, so now that I have my balance reaction, I'm going to go through and try to balance something where, say, I'm giving you a particular mass. So let me rewrite my chemical reaction at the top. Okay, close page. All right, so let's say that I start out with 10 grams of CH4, and I want to know how much oxygen do I need to have a complete reaction with all the methane. Okay, so essentially how much mass or how much matter do I need to react with 10 grams worth of methane gas to produce carbon dioxide and water completely, so that all the CH4 is being used. Okay, so to do this, the first thing that I need to do is figure out my molar masses. Okay, so when in doubt, right, change grams to moles. That's probably going to get you part of the way on any of these questions that we're going to be answering. Okay, so let's start out with methane gas. Okay, so methane is made of 1 carbon and 4 hydrogens. Okay, so for each carbon, we're going to have a mass of 12, right? So I'm just going to use whole numbers today for ease, right? It's going to be 12 grams for every 1 mole, or 12 AMUs. For hydrogen, right, each of those is going to bring 1. So I've got 1 carbon, 4 hydrogens. So if I add up my total mass, I've got 12 plus 4. So each methane is worth 16 grams per mole. So that means that I would have to have 16 grams worth of methane gas to have the equivalent to 1 mole's worth of molecules. Okay. All right, so now let's figure out what I need for oxygen. Okay, so for O2, right, that means that there are 2 oxygens together. Each oxygen has a mass of 16. So that means that for my final value, I would have 32 grams. That's how much mass it would take to equal 1 mole. Okay. So again, remember, a mole is the same number of molecules or atoms, right? It's just that to have that number, I would need to weigh out 32 grams of oxygen gas to give me a mole's worth of it, right? Versus methane, which is heavier, right? It's a larger molecule, so it takes less mass to give me the same, or less mass to give me the same number of molecules. All right. So let's go with our next step. Okay. All right, so I know my molar ratio now, so I've set up my conversion factors. So now I can figure out how many moles I actually have for each of the things that I'm going to be measuring. So let's start out with what I know. I know that I have 10 grams of methane gas, okay? And with those 10 grams, I want to figure out how many moles I've got. Because again, in my chemical reaction, it allows me to make the comparison of the molar ratio. So if I figure out how many moles I've got worth of this, I would need twice as many moles of that for oxygen in this case. Okay? So I've got 10 grams. I'm going to use dimensional analysis, right, to help me compare and find my value for moles. Okay? So I know that in order to get rid of grams, right, grams needs to be in my numerator or in my denominator. Moles needs to be in my numerator because that's what I want. And then that will give me my final answer. So already looking at my relationship here, for every 16 grams I have 1 mole of, moles? I have 1 mole's worth of methane, so I multiply that across. So my grams cancel out because they're in opposite parts. So I'm left with mole over 16. So if I take 10 divided by 16, I get my final value, which is 0.625 moles of CH4. Okay. So one good habit to pick up is that whenever you're labeling anything and dealing with moles or dealing with stoichiometry, since you're dealing with grams and moles quite a bit, always list what chemical compound you're dealing with. That's probably the best way to make sure that you keep track of all of the stuff that you have. All right, so I've got 0.625 moles of CH4. So that means that it's going to have to react with 2 moles, right, of oxygen gas. So 2 moles worth of oxygen gas to get me to my final answer. All right, So the next step, the next thing that I want to do is I want to figure out how much oxygen I'm going to need in order to do this. Okay, so I know that I've got 0.625 moles worth of methane. I need twice as much of that in order to make oxygen react. Okay, so I'm going to take that value, right, and solve for it. So to set that up, what I'm going to use is the equivalent ratios that I'm seeing in my chemical reaction to help me figure that out. So I know, looking at my chemical reaction, that for every 1 mole's worth of CH4, I need 2 moles worth of oxygen. So I'm going to set up another conversion factor using dimensional analysis to help me figure out what amount of oxygen then I'm going to be using in terms of moles. Okay, so if I have 0.625 moles of CH4, I know that for every 1 mole of CH4, it's going to take me 2 moles of O2 to react at all. Okay, so using that information, then I can set up my values to calculate this. So my moles for CH4 cancel out. I multiply 2 times 0.625, and that tells me that I would need 1.25 moles worth of O2 gas to react all of that methane. Okay. So now that I know how many moles I need, I can figure out, lastly, how many grams I need. Okay, so I have 1.25 moles worth of oxygen, and I know that for every oxygen or O2 molecule, right, for every 1 mole of that I have a mass of 32 grams. Oh, sorry, that should be 36 grams. Oxygen is, wait, I'm blanking. No, I was right, 32. I don't know why I'm getting that wrong. All right, 32 grams. Okay, to figure out my final mass. Okay, so if my moles cancel out, I will multiply those together. So 1 times 32 would give me 40 grams of oxygen gas in order to react all of the methane fully. Okay, so again, these questions can be kind of long. There's a lot of steps, and there's a lot of stuff that you've got to keep track of. That's why we set up these tables, to make sure that we're modifying the correct units as we go through. So in the end, that if I start out with 10 grams of methane gas, I need 40 grams of O2 gas to do that. Okay, and again, this all comes back to the molar ratio, right? For every 1 mole's worth, I need 2 moles of this. Okay, so I have to find the ratio or the relationship or values, right? And again, it's not going to be perfect. It's not going to be like twice as much oxygen, so like 20 grams. It's, since each of these things require a different number of atoms or molecules to produce the same number of the molar mass, right? You've got to keep track of those values as we're going through and editing these or calculating these. So let's do an extension of this one where we're trying to predict how much the product is going to be. Like, let's say I take this reaction, right, of CH4, and I want to know how much carbon dioxide I'm going to be producing based on how much methane I started with. Okay, so I'm going to write my chemical reaction again. All right, so again, we want to ask what amount of carbon dioxide gas do I produce in this reaction. Okay, so again, assuming everything is reacting. Okay, so I don't know the molar mass of carbon dioxide, so I can figure that out. So for each, there's 1 carbon, 2 oxygens. Each carbon has a mass of 12. Each oxygen has a mass of 16. So if I add those up, right, that gives me a total value of 44 grams for every 1 mole of CO2. So I know that I started out with a reaction that had 6.2 or 0.625 moles of CH4. Okay, if I look at my reaction, which is again looking at this value here, for every 1 mole of CH4, I would produce 1 mole's worth of carbon dioxide. Okay, since I'm only starting out with 0.625 moles of carbon dioxide, that means I can only produce that amount of CH4, right? Because I know that for every 1 mole of CO2 I produce in my reaction, I am using 1 mole of CH4. So again, these cancel out. I multiply this across, so I get 0.625 moles of CO2. Okay. So like before with the oxygen, I can plug in this value, multiply it by its this conversion factor, and figure out how many grams of carbon dioxide I produce in this process. Okay. So I've got 0.625 moles of CO2. Okay, and I set up my conversion factor so that I'm canceling out that. So I know that for every 44 grams of CO2, I have 1 mole's worth of it. So if I multiply those across, my moles cancel out. Right? If I multiply 6.25 times 44, I get a value of 27.5 grams of CO2 produced in this reaction. Right, so we can utilize this to not only predict what we might need to react in order to utilize all of some other reactant, but we can also figure out how much we produce per particular product. Okay. All right, so what I've given you is a list of some different chemical reactions and some practice questions for doing stoichiometry. So what I would like you to do is answer those questions, okay? And then you're going to turn those in. So if you've got anything that you want to follow up on related to stoichiometry, please let me know.